case you'd like to reference this in the future. With that being said, we've got an exciting session today on electrical safety, autoclaves, and reusing PPEs. And I'd like to hand this over to Erin to take us through this.
Okay, thanks, Benjamin. So as Benjamin said, welcome. This is session 9 in our series. We've talked about a lot of equipment so far. Today we're introducing one new one, which is autoclaves. We'll also talk a bit about electrical safety. And I'm going to tell you a little bit up front about reusing N95 masks as part of your PPE package. If you're new around here, Project Echo, we like to have our conversations with a foundation of love and respect. Please respond kindly rather than react if you disagree with someone. Please test your equipment ahead of time when you can. You can mute your microphone in the bottom left-hand corner of your screen. Also remember to unmute before speaking and introduce yourself as well. Speak clearly. If you're in a large room, get close to your microphone. And if you have any issues at all, you can chat us or email us at assisthtm@assistinternational.org. So we had a session, not as part of the biomedical series, but as part of the clinician series. It was done by N95 Decon Consortium. What they are is a group of scientists and students that came together sort of as part of COVID-19 response. They just wanted to do their part in preparing the world, specifically low and middle income countries, with ways to reuse N95 masks, especially due to the shortages caused by COVID-19. You can view all of their technical reports and their fact sheets at their website. They also have a few webinars if you need more information than what I'm presenting today. You can also view their full session done with Assist International last week, and you can see that at this YouTube link here. They gave a pretty strong disclaimer that all of their data and experience pertains to N95 masks that were certified by the U.S. National Institute for Occupational Safety and Health. So there could be a lot of variation between the masks that you're using and the masks that they've tested. So make sure you're aware of that. They talk about the exact makes and models that they've tested on their website a bit more. So the factors that they're concerned with when it looks at evaluating how effective PPE processing is that they look at these 4 things. So filtration efficiency, that's, how many particles is it removing from the air that you breathe? Fit test, is there a tight seal sort of around your mouth and nose? Bioburden reduction is how well the virus is deactivated by the process, and also hazards that could be associated with some of the different methods. For example, UV light can contain risks for things like skin cancer. If you're using things like bleach, there's a lot of risk that you're going to breathe in chemicals. So those kinds of hazards they're trying to avoid. Just a quick refresher, PPE is actually the last sort of barrier to you getting contaminated with a virus like COVID-19. There are a lot of things you can do before that help prevent it. So for example, elimination, don't go around the virus, but if you have to go around the virus, you can do some things like isolating people from the hazard. That's, putting COVID patients with COVID patients, changing the way people work. Anybody who doesn't have to go into a patient room shouldn't. And then the last barrier is PPE. So we'll talk a little bit about N95 masks specifically, but here is just as a refresher, sort of what PPE you should be wearing in sort of various roles within a hospital. If you're not contacting patients, then you're probably okay with just a surgical mask. If you have direct contact with patients, you should be wearing masks, gloves, gowns, and face protection. And again, all of this should be disposable where possible. BMETs sort of fit into a mix of some of these roles, but somewhere between here cleaning COVID affected areas, and here aerosol generating procedures is probably where you want to be. And again, this is from the WHO and the CDC if you need more information. So now the big question we've been getting is, what if I don't have access to PPE? What if I don't have access to a new set of PPE every time I work? There are some options if your access is limited. So first is extended use. In most cases, you're supposed to change your PPE with every patient. For VMEDs, it's a little bit different. It's not ideal, but you can consider using gloves or masks or goggles for an entire shift. If you're going to reuse them beyond one shift, you should remember that the outer surface could be contaminated, and that will affect the way you put on and then you take off your PPE. Also, one point they drove home very strongly was that you're most at risk for contaminating yourself with the virus when you're donning and you're doffing. And we've talked a bit about that in our very first session. You can go back and watch it there. But the WHO and a few other organizations have some really great videos if you're not sure how to put on and take off your PPE. Number 2 is decontamination and reuse. That's mostly what we'll talk about today. It's not as good as replacing each time, but there are quite a few options that make a lot of sense for most hospitals and can be used to decontaminate. Lastly is substitution. In some cases, if you don't have a particular item, you can replace it with a different item or a different process. For example, if you don't have gloves, hand washing is actually a pretty good replacement for that, as long as you do it consistently and you do wash your hands with soap for 20 seconds or more. There's also homemade face shields and goggles or cloth masks if you don't have N95 respirators. Again, this is a last resort, but it is something you can do. So an effective decontamination measure is measured against these 4 things. I mentioned them before. It has to preserve filtration, it has to preserve the fit around your face, it has to actually kill the virus, and it also has to not introduce any more hazards. These are some methods that are not effective but have been recommended by some people. So when it comes to N95 masks specifically, you can't really use soap, alcohol, bleach, or gamma radiation. Those things actually damage the mask filtration itself. So even if there's no virus on the mask, it's not actually protecting you from breathing in anything. And then on the right here, you see some options like overnight storage, UVA-B, UVA or UVB, and also sunlight. These do not actually inactivate the virus, even though they don't damage the mask. It's actually not protecting you from COVID. So there are 4 methods that are effective. The first 2 are here. The very first is vaporized hydrogen peroxide. There's a small caveat that if your mask contains cellulose, and some do, you cannot use this method. They react poorly. But otherwise, it's great for deactivating COVID, the SARS-CoV-2 virus, which is COVID-19. It also will kill other highly resistant bacteria. You can use it about 10 to 20 times in the same mask, but you should make sure you check the fit every single time you use it. Method number 2 is UVC, and just a caveat, this is not UVA, this is not UVA or UVB. So if you've ever seen, a UV machine in the salon, if you have one for your greenhouse, like those are not the same thing. But if you have UVC waves, it's a very specific range of wavelengths. That is actually germicidal, and you can use it to clean and sort of decontaminate your mask. It will kill the COVID-2 virus. It can be used for up to 20 cycles. There are some models and some dosages that only work for up to 5 cycles, but it is an option. UVC can also harm the straps and make them much more brittle, so you should be careful about that. And from what I hear, you can get a UVC lamp for something like 300 USD, depending on where you are. You should also be cautious when you're using a UVC lamp. It can cause some eye and skin damage, and it can also produce ozone. Methods 3 and 4 are probably the most attainable for most hospitals. Number 3 is humid heat. You're probably familiar with autoclaves. We'll talk more about that later. What research shows is that dry heat isn't enough, and also that high temperatures can damage masks. So depending on the mask, your results may vary, but the settings shown here, so between 70 and 85 degrees Celsius, humidity between 50 and 85%, and a target time of at least 1 hour are usually sufficient to kill the virus and also decontaminate your mask without damaging anything. I think typical autoclave settings, maybe Guna can talk a little bit more about that, but typical autoclaves will hurt your mask more than they'll kill the virus. So you should be cautious, but go ahead and target these settings and you should be okay. Number 4, this is again a last resort. If there are no other options, if you have none of these methods available to you, you can store the mask in a breathable container for at least 7 days. This significantly reduces the risk of exposure. It's not perfect. There's not a ton of data to actually confirm this. But if you have no other option, this might work for you. Overnight storage is not long enough. You also, if you put it in a sealed container, it will not be as effective no matter how long you leave it out. So please be cautious with this, but keep it in mind if you don't have any other options, if you don't have more PPE, you can store it in a breathable container for at least a week and then reuse it after that. That's all I have. If you have any questions, leave them in the chat and we can talk about them later. And again, there are a lot of other resources once you get this PowerPoint for you to go ahead and review. And with that, I'm going to turn it over to Guna, and he can present on electrical safety tests.
Right. So we're going to talk about electrical safety tests. So before that, we need to know what is electric shock. I think everyone knows that the effect depends on amount of current flow, part of current flow, and duration of the current flow that's going to give impact on your body. So you can be very dangerous, you get minor injury, even death. So when you talk about main source, certain country use 220, some 240, and some country 110, depends the country. But when you connect to some 220 volt with an electric shock, it can cause quite a lot of harm and dangerous thing. So this is a normal connection of electrical wiring that you're going to see in home with the ground, neutral. These are 3-phase, line 1, line 2, and line 3. These are normally what you see in a normal electrical wire with 3-phase line connected to the earth. Okay, class 1 device normally is a grounded line, so always a link to ground, all that. So this is commonly you're going to see on household application that they got a ground line, all that. So this is the electrical wiring with the grounding, all that. So when you touch, you are properly ground all that, you are safe. But if you're not grounded, you're going to get in trouble. So this is the same thing, but one of the ground is broken, so ended up you're going to be the ground line, so you're going to get experience of electric shock. So leakage current on the equipment, what happens is metal chassis, all this body that with metal casing, all that, when there's a leakage, for example, live broken from the main line and touch the metal chassis, what happens is when someone touch, you're going to get electrocuted. Like for example, autoclave. Most of the big unit of autoclave is they have a metal case and should be grounded, but one of the wire going to touch the body of the chassis or something like that. Eventually, with the earth, is going to trip if you got proper fuse and circuit breaker, all that. But if there's you don't have any other safety precaution, what happens is someone going to get hurt. So when you talk about leakage current with the idle installation, due to less idle installation or anything that between the wiring and the circuit breaker, all that is missing, probably you're going to get electrocuted. So usually small current less than 500 microamp, if there's a circuit breaker, is going to trip. If not, someone going to get electrocuted. It can be very dangerous. Grounding play a very important role because it carried the leakage current to the earth line safely and move away from your body, because your body got some impedance. So if a proper grounding is there, it's going to go through that particular grounding line. So when you touch the equipment, it's still safe because there's a proper grounding. So anything goes wrong, there will be a larger current go through, there will be a fuse blow, or circuit breaker will trip. Okay, normally when you got electrocuted, in the normal condition, we call macro shock, and there's a micro shock. So these are two type of different scenario. Okay, different type of electric shock, macro shock and micro shock, and depends on the path of current and point of entry. So that's a difference. So when you talk about macro shock, current that flow through your body, but not directly connect to your heart. So it's not directly linked to your heart, but it's going to pass through. And macro shock normally will be somewhere 10 milliampere. That current that through the body exceed more than 10 milliampere, and is going to look for a ground. For example, a macro shock. If you see a washing machine or something like that, so if there's not a properly ground and the wire broken, it's going to go through your body. So you can see your body become like part of conducting. So that's where you get electrocuted. So micro shock, so it happens to the patient, direct contact to the heart, usually cause of unrelated macro shock. So it's not a macro shock, but it's a smaller current, but it's connected to the heart. So it's generally leakage on line, operating equipment, differential voltage between the ground and the surface, or larger current in the grounding system that going to pass through. So this normally happen for in the patient condition or something like that. So we call it micro shock. So it flow into the electrical connection to the heart. So you see the drawing is going to go through your body, but it's going to go through your heart. So macro shock normally current flow via direct electrical connection to the heart. An example like pacing, fluid catheter, infusion line, all that, and ECG line, all these can cause microshock. So this is example of microshock. So one of the equipment, for example, ECG device, there's a faulty on grounding, or maybe you don't have a proper grounding line. So what happens is there's maybe a leakage on your faulty equipment. Is going to find for a new ground part. So it's going to go through that particular ECG line near to your heart, all that, and find for a new ground. So it's going to go through a contact of a lower resistance point. So this what happened is the flow going through the body. So from faulty equipment, you can see the cable are going to the body. From the body, it's going to the ground line. So to make sure that the leakage current and all these are in the range of safety, that's a standard that you need to follow. IC 60601 normally represent medical device manufacturing. All the equipment that manufacture, medical equipment that manufacture, have to follow this particular standard. Then AMI is according to the American standard. And IEC 62353, when you do servicing, you can follow this particular standard. And for lab device, there's IEC 61010 lab device standard. So you have to follow that particular standard when you do electrical tests. So in IEC 60601, there's a lot of symbols and variety details that you need to know when you do a safety test. So for example, the terms that they use, equipment under test, EUT, DUT, all this. EUT means equipment under test, then DUT is device under test. And apply parts. Apply part is the like ECG, SpO2, all this, patient connection, type of connection, all that. Then F-type, apply parts that isolate between the ground and the equipment. For example, class one equipment is always referred to grounding. So you can see ground reference point and class one. These particular symbols you can see on the medical device, at the back of medical device, or sometime at the side of the medical device with the serial number, all that. And class two device is double insulated. So you're going to see this particular symbol on the particular medical equipment. And remember, class 2 device, normally you don't need to do any ground testing because it doesn't have ground, but sometimes you're going to have a ground connection, but it doesn't work sometimes. Depends on the type of manufacturer. So you have to refer to the manual sometime if you see a 3 connector. So you have to look into the user manual. Sometimes it'll mention functional ground or not functional with the class 2 symbol. And type B, BF, and CF, these are apply part that you're going to see this particular symbol where you connect your ECG line, SpO2, NIBP, all that. So when you see this type of symbol, type B symbols is representing for ground reference like NIBP or something like that, and not suitable for direct cardiac application for type B. And type BF, it has certain comply F-type applied part that have isolation and protect against electrical shock. So you can see type BF and type BF with defect proof. So the defect proof means when you're applying, for example, ECG on the patient, that particular patient need to be defib. You can defib the patient without removing the ECG cable. That's the reason they mentioned defib proof type BF. Okay, and cardiac type CF apply part is for cardiac normally. So you can see type CF and type CF with defib proof as well. So this is checklist according to 60601 and 62353. You can use this as for reporting purpose when you do electrical safety. So device current, you have to measure device current, voltage, earth ground wire resistance. Installation test depends on the type of analyzer that you use, electrical safety analyzer. Some is optional, some are built in together. And you got earth leakage current, enclosure leakage current, and patient leakage current. On patient leakage current, you got lead to earth leakage, and patient auxiliary current, you got lead to lead leakage, and main on applied parts lead to isolation leakage. So these are particularly when talk about AP applied parts, you are talking about like ECG, all that you're going to measure. Okay, when you do a connection between AST and medical device, always first step, check for the classification of the medical device. Is it class 1 or class 2? And check for the type as well. Is it type B or BF or CF? So when you do the connection, you should do, if class 1 device, you have to do the chassis connection, go to the grounding line, and the power line have to go to the electrical safety analyzer and plug in the main power source to the EST. And you start to check the device by using the display. So when you see the voltage for class 1 device, when you do the grounding, check the grounding, install all that, and the image will show the reading of the actual voltage is 219, the supply, incoming supply, and you see the small 2 green dot line that indicate the neon incoming power status, whether the wiring connection is properly connected or not. So if you got two green line, the wiring is correct. And the third connection will be measuring your device current. So you're measuring the device current, the current that used by the device. It should be 0.18. So you're measuring device current, and then after you measure the device current, you have to measure the resistance between the ground from the power cord to your patient monitor. So the earth resistant ground bonding, so the reading is somewhere 0.09, and natural limit should be somewhere 0.1 to 0.3 at a detachable power cord according to IC 60601 62353. This is the international standard. And resistance between chassis, test lead, and the earth line. So this is how it's done. So connection between EST and medical device part for earth and ground leakage. So when you do earth and ground leakage, what happens is your EST intend to open up the ground line. It create a single fault condition. So when you tell on normal condition, that means the earth is already open, and you're going to get reading somewhere 90 microampere. So you can see the reading should be below 500, and when open neutral should be below 1000 microamp. The SFC is single fault condition, and NC is normal condition. Normal condition means your wiring, everything in good, proper condition. So the single fault, normally when you tell open neutral, you're going to do simulation on the electrical safety test by pressing the switch on the device. You're going to open up the neutral line, and when you open up a neutral line, you're going to get reading somewhere 178, something like that. So it's going to increase the reading because your neutral is open and your earth is open. The leakage current is looking for different part. So this is how you do the testing. So on enclosure leakage, you have to do like 1, 2, 3 normal condition, open earth, open neutral and reverse condition, and normal condition, reverse main, open earth, reverse main. So you have like almost 6 steps to comply, and see these are things that you do like single fault and normal condition. to verify whether there's any leakage coming out from any of these particular condition. If the leakage above this particular range, that means something wrong with your device that you need to look into it. So you can see on the apply part, connection between apply parts. Okay, and the apply part play a very important role as well. So when you talk about patient setting, a low as 15 microampere, it can result a fatality, can kill someone. So it's fatal to the patient because normally when you are talking about patient condition, they are weak and they are sweating, all that. So a smaller current, easy to pass through. So it's quite dangerous actually. So when you do apply part on patient, for example, you can see on this particular thing, we got ECG line installed. So when ECG line installed for CF, it should be 10 and BF 100 and B 100. So this is the range that you're going to do. And you can see all the LED. That means all this LED is showing you are measuring the particular apply part in the group. So patient leakage current and lead to earth, you are measuring the lead referring to the earth. So when you are measuring lead to earth, you are checking the leakage between the lead referring to the earth. So in normal condition, it should be below 10 for CF and BF 100 and B as well. And open earth should be below 50 for CF and 500 for BF and B. Open neutral, same thing, 50 to 500 BF and B. So these are standard reading according to the IC 60601 and 62353. So patient leakage lead to earth, you can see, you can do the measurement in group or individually. Sometimes if your lead isolation is not good, you're going to get reading more than 10. That means it's quite dangerous to use on the patient. Like this is 1, so it's quite low and safe to use. So lead to lead. This is another test that you're measuring between the leads. You're comparing lead 1 to lead 2, lead 1 to lead 3. You're comparing each lead, whether there's a leakage between the leads. So this is another method that you need to do individually. But you have to connect all and you're measuring individually, lead to lead test. You're sensing the current between the leads and checking any current differential and any auxiliary effect on the current bias. So this is the range. It's almost similar with the lead to earth. And on the lead to lead, you can see that's a reading of 0, reading of 1, where normally the lead to earth and lead to lead, the reading will be almost similar. The reason is if the isolation is good, you're going to get almost similar reading. One is you are referring to earth, another one is you are referring to each lead. So the reading always will be similar actually. If lead to earth fail, chances of lead to fail is quite high. So main on apply parts, MAP, this is another measurement that you are testing between the lead as well. but you can do individually or in grouping. Normally, the best method is do it on the group and see if the reading is above this particular range, and try to do one by one by changing the setting for the patient apply part setting. So normally, what happens is one of the lead is have contact with a live wire or something like that. You're going to see whether the other remaining leads have some effect with that. So when one of the line with 110 or 220 voltage contact, the other lead should be less, should measure less. That's what you're measuring actually. For example, you see it show 24 is below than 50 for CF. That means it's good condition actually. So this is on the apply parts. So this is how you do ESC electrical safety tests for by using EST analyzer. Okay, next topic we're going to talk about autoclave. So these are one of the key device that you use to clean some of your medical device, all that medical accessories, all that. So operating principle, everyone knows how it works. So volume of steam, keep constant, and temperature and proportion to the pressure. So that's how the Boyle law say, and this the law that we use to run your autoclave most of the time. So purpose of autoclave, everyone know, use in laboratory material and object to sterilize all that. So you going to clean test tubes, pipette, all this. Sometimes you're going to use this to for your ventilator tubing, the multiple use tubing, all that. You need to use autoclave to make sure it doesn't to disinfect the particular tubing, all that. Some might use for your surgery tools, all that. So common type of autoclave, you're going to see gravity method, horizontal pressure, vacuum, and liquid method. So horizontal or down displacement autoclave is a method that almost similar with the gravity method. So you're going to use that for biohazard waste, glassware, unwrapped goods, all that. And so the horizontal or down displacement autoclave is a gravity displacement autoclave. So these are one of the common use in hospital as well, that cold air escape through the bottom of the chamber and steam are displaced from above. So a lot of valves that involve that going to pressurize all that in the chamber. So you can see the diagram of it. So electrically operated autoclave, they got fully automated and semi-automated, depends on the brand and the model you are buying. So these are downward displacement autoclave or gravity type, gravity displacement unit. You can see how the method is done. So using the heating element and water, you produce the steam, and the steam which lighter than air are forced into the sterilized chamber and move downward. You can see the blue one that moving downward. Then eventually the air move out through the drain. The blue one, the red one is where the steam going in and desterilize this on this chamber, all that, and it's going to move towards down and going out. Once the temperature in chamber sufficient, it will and automatically close the process, and it'll go through that particular valve and go down again. So that's how it works. You need to create pressure and steam, and certain period of time is going to do the sterilization process. Then vacuum assist autoclave. So vacuum assist, there's a sterilization chamber and steam. So what happens is a negative pressure displacement unit. So it's going to create a vacuum. So there's a vacuum pump that going to, we see the black one, that's a vacuum that going to remove all the air from the chamber. Once it remove air from the chamber and steam is created and will be going into the chamber, and the process will be begin with the pulse of steam and pressure. And this type of autoclave are very suitable for instrument. Most of the instrument they use and very commonly used in hospitals. When you talk about vacuum assist autoclave, you need to know that there's a heating element, temperature control, pressure sensor, the chamber, door gasket, all that, and solenoid valve, water level sensor, steam generator, vacuum pump. These are 9 type of component that you can normally you're going to see inside vacuum assist autoclave. So the 9 type of component you can see very clearly. Heating element is very, very important. Temperature control, where you control the temperature, all that. Pressure sensor to measure the pressure inside the chamber, everything. The chamber itself, very important. Door gasket to avoid leakage, make sure the gasket is good condition. Solenoid valve to control the process. Water level sensor to measure the water level. Steam generator and vacuum pump. Most of the place that I have been traveling, like some hospitals, there's always issue with the vacuum pump because of certain issues. What happens is the vacuum pump is not working properly. Sometimes steam generator is not working properly due to the water condition. So when the vacuum pump don't work properly, you don't get a proper heat relevant. So what inside the chamber, you're not going to get equal heat. So all these are one of the common problems. Some places the door gasket is leaking. So eventually you don't create a proper pressure. So you have to look into this particular device. Some of the component have to take care to make sure it works properly. So when you talk about vacuum assist or pre-vacuum autoclave, so air evacuate rapidly from the sterilized chamber at beginning of the cycle, creating a vacuum. So the steam penetrate and sterilize occur very rapidly. So removing air and creating vacuum in the chamber, and steam ascend to penetrate and sterilize. A second vacuum cycle to withdraw the moisture after the sterilization process and facilitating drying of the load. So purpose of second vacuum is to make sure to remove the moisture. So these are normally most of these autoclave are connected to central boiler to get the steam and have larger capacity and fully automated and fail safe. So these are normally you're going to see the bigger unit in CSSD or something like that department that doing sterilization, all that. And most of it nowadays using computerized autoclave, and you can do the cycling and setting up all that. So sometimes what happens is you can abort the function of that. So the controller also very important. You need to keep make sure that you check all the controllers are working properly. So vertical pressure, we used to call cooker autoclave. It's operate on a household pressure cooker and commonly used and practice. So vertical pressure use air vent on the top and manually close after all the air has been evacuated. And disadvantage is air may remain and trap inside the steam and cause a low temperature to reach in this area. Certain area is not fully covered because these are sometimes manually operated, and sometimes because of human error, you're not going to get a fully sterilized all that. So at the same time, it's not automatically drying cycle, so item may be slightly damp at the end of the cycle. So you have to dry them before storing it. Okay, classification of autoclave and type of sterilization cycles. So normally you're going to see in hospital type N and type B are very common. So type N unit does not use vacuum to remove the air. So type N is unwrapped solid instrument for immediate use. So these are down displacement or gravity. So these are suitable process. Normally you use unwrapped item, solid instrument, all that immediately you want to use. And B type is the vacuum type. So you can use on wrap and hollow instrument, which means a piece of like portion load, draper, gown, even your ventilated tubing, all that. Even you can use on dentist, plastic surgery and day surgery, all that. So these are two types that you normally going to see in hospital. So class B and versus class N. So when you talk about class B, sterilization is a vacuum thing, autoclave, vacuum pump and pre-vacuum, and cold air removal and post-vacuum for hot air removal and venting. So that's how it works on class B, and provide better penetration and sterilization for wrap, hollow and prosthetic instrument. The time is shorter sterilization time and shorter drying time and fast total cycle time. So this is the advantage class B sterilization. And class N sterilization, no vacuum function, air removal performed by the gravity displacement, drying performed by compress or natural venting by the pressure itself, long sterilization time, long drying time required. So this is the difference between class B and class N. When you talk about autoclave, you have to always remember minimum to get a good performance autoclave. You need to have a minimum of 15 psi and temperature and the time. These three play a very important role. If one of it fails, you're not going to get a proper sterilization perform. So always remember that. So when you talk about when you're doing work with autoclave, all that, and as a BMAT, always remember PPE is very important, like eye protection, lab coat, and closed-toe shoes, because you're dealing with heavy stuff and wet surface, all that, and PPE and glove, all this very important when you're dealing with autoclave. Preventive maintenance, always clean all the filters, usually water and air line, all that. Make sure all this using water and air pressure to clean all the line, all that, and the filters. Fill the water with the tank up to maximum limit. Use distilled water. Always make sure you use distilled water, because most of these autoclave are designed to work on distilled water. If you're using normal water, the lifespan reduce, and I can show you later what will happen normally. Check the manometer function as expected using digital pressure meter. You can do a pressurized test on that particular manometer, whether it's working properly or not. At the same time, you can run the system and see the pressure, compare with the external connection. So check the accuracy temperature reading using DPM. The DPM have external pressure temperature tester. You can use that particular temperature probe to check. Activate the safety valve manually by pressing the check valve, the safety valve. You're going to see whether the safety valve is releasing the pressure or not. So you have to be careful, because you're going to get hot steam coming out from there. And conduct a general sterilization process. Write down the pressure, temperature, required time, all this. See the phase cycle, whether it's working properly, and write down inside your report. And verify the function and the tolerance defined by the manufacturer. Refer to the service manual. Sometimes you need to refer to the user manual, because every brand and model, they got their own setting. And check abnormal sound on the solenoid, because he's using quite a lot of solenoid valve. You need to hear whether the sound is changing properly or not according to the time, all that. Clean the chamber and remove lime scale, if any. Advise to use only distilled water, very important. Check the earth leakage current, protective earth, using electrical safety analyzer or multimeter. So you need to check whether your autoclave is grounded properly or not, because safety issues. Remember, normally when you talk about bigger autoclave, there's always the area is wet, all that. So you need to be careful. If the device is not grounded, anything can happen. Chances of getting electrocuted is very high. So lime scale, so you can see what happened to your on your heating element. So on the heating element, you can see a lot of lime scale, and some of the piping full with lime scale as well. So all this can cause blockage, and maybe the copper pipes get blocked with lime scale. And initially what happened is your autoclave not going to complete the full cycle performance according to the setting, and it's going to fail. So always check if the particular heating element, all this with lime scale. Always remember, use distilled water, and make sure that you clean the heating element. If there's a leak on the heating element, you need to change the heating element, because what happens is it's going to trip the system. power failure, all that. So make sure when you clean the lime scale, you have to clean it properly and wash it properly. Use plenty of water to clean and remove all the lime scale from the copper tubing, all that, to make sure there's no blockage on your solenoid valve. Sometimes what happens is your solenoid valve not going to perform properly due to these particular dirts, all that. So make sure you remove the lime scale on the hot water boiler, everything. Benjin, can you change the slide? Yeah. So this is what you get with your heating element. So you can see how bad is the heating element. This can fail the system actually. And you can see the copper tube, the piping full with lime scale. This can block the system and create unwanted high pressure. What happens is if your safe valve is working properly, you're going to get pressure blowout, all that. So you always make sure you clean it and make sure you use distilled water to avoid lime scale. So to do a performance indicator test on autoclave quality assurance, there's few ways that normally you do. You can use the physical check by using the like instrument, by you checking the temperature, pressure, all that. And you can use the chemicals sensitive autoclave tape. You can see the before and after. Before is the yellow line, and after the test you get the line become black. And another one is you can use biological tests by using the bacteria spot test. So this will give you the actual resistance of to the steam sterilization. So this is another method. Okay.
All right, thanks, Tina.
Welcome.
So we're going to move into our discussion phase now. I'm also going to launch the poll. As Benjamin said, this is what we use to get your feedback and plan future sessions. So take a moment and fill that out for us if you can. If you're on your mobile phone, there will be a green bar at the top of your screen, and you can launch it from there. And we have a few questions. Gunnar, maybe I'll start with the ones on electrical safety. Chris asked, how does class 2 grounding differ from class 1?
Okay, class 2 and the grounding is maybe used for the power supply only, but it doesn't affect any of your ECG line, all that. Some they put grounding for the power supply only, but it doesn't have any effect with the main line.
Okay.
And it's very rare actually.
Sorry, class 2 is very rare?
No, for grounding for class 2. If you see actually for class 2 there's no grounding actually, but some design they intend to put the equipotential line together for the power supply purpose only, but it doesn't affect on the ECG line. So there's isolation between the power supply and the device. For example, if you see like adapter using a separate power supply, but the power supply is class 1, but the device is class 2. Is using a 12-volt connector. So they design such a way.
I see. Thanks, Gunnar. The next question is, how does one conduct safety tests where the analyzing gadget isn't available?
That's an interesting question. You can do like a basic test for, if you don't have a safety test, you can do for class 1, you can do check the grounding between the plugs, the 3-pin plugs. If that particular ground and the equipotential ground, by using multimeter, check if there's some reading that conduct. At the same time, make sure that your electrical wiring in the hospital are grounded properly. This is another best practice, but without electrical safety, certain tests you cannot perform. You are limited with the testing.
Okay, and there's another question on electrical safety from Solomon. And Solomon, we may need more details from you, but maybe Guna will understand your question better than I do. Can you perform test automation and onboard memory for the electrical safety analyzer EST presented in this PowerPoint?
I think he's referring to like ultrasound, all that. So what happens is, like ultrasound, you can do certain tests, but you cannot do you cannot power up the unit. So you can do ground and chassis tests and earth leakage, but do not power up the unit.
Solomon, please let us know if that is in fact what you meant. I'm actually going to share my screen to answer one of the earlier questions. Somebody asked, what is the level or effectiveness of UV light disinfecting killing COVID-19? So I'm going to go ahead and share real quick. So everything that N95 Decon does is well tested and well documented. So if you need more information on the studies that they've done, you can feel free to go to their website. They will help you. But this is sort of what we're talking about when we say UVC light. This is the range you need to be in for it to be effective. You can see UVA here, UVB here. Those are both valuable for other purposes, but they're not germicidal. You have to hit this peak in this range between 200 nanometers and 280 nanometers wavelength. And what you actually also need to do is provide this much power here. So that's 1 joule per centimeter squared of UVC in order to actually inactivate the virus. Anything less than that may or may not kill the virus. It's considered germicidal, but it may or may not affect SARS-CoV-2, the actual COVID-19 virus. And that yields 2 log reduction, just so you know. I see a few more questions. Can you clarify the sterilizing plastics like the patient circuit and the bacteria filters? Guna, I think that one's for you.
Yep. For a patient circuit, yeah, you need to know your patient circuit is multiple use. If multiple use, you can follow that requirement they give, and you can do the sterilization. Bacteria filter, there's some bacteria filter can be sterilized, but most of them not really, because once you get the bacteria filter wet, it's not going to perform. You're going to get a lot of turbulence line. So normally the bacteria filter it should be single use.
can we just quickly clarify, didn't we go over the patient circuit sterilization in session 1, was it? If I recall
Yes.
correctly? Yeah, and so, I mean, there's a little bit more information we put together in session 1 slides. You can see, I think Guna, you may have even presented on different temperatures and pressure requirements for
Yes.
reusable circuits.
Yes, that's on the first session, yeah.
Yeah, and I'll go ahead and leave the link to our website in the chat right now so that you all have it. And that's where you can find previous sessions, both the PowerPoints and the recording. I want to leave a moment for some more questions. If anybody else wants to share their experience or ask a question, have a comment, please feel free. Guna, another one for you. Is there a way to repair a damaged heating element, like after limescale covering?
Normally, if your heating elements leak or you already got start to get old, you cannot repair actually. It's difficult to repair because it's going to affect the internal part of it. So eventually what happens is you're going to get trip, circuit breaker, all this. So try to avoid that particular thing. Limescale, always avoid limescale, you need to make sure that you use distilled water.
Guna, how often should people be doing preventive maintenance and cleaning limescale off of their autoclaves?
If you use distilled water, normally you don't get limescale, but if not, you have to do like every 3 months, make sure that heating element doesn't have any leak. Make sure you clean the surface properly. That's an important thing.
That makes sense. Okay. I believe that's all the questions we have. Oh, no. So we do have a clarification on that question about ultrasounds. So can the electrical safety analyzer be connected to a PC? It seems like Solomon is thinking of automating the testing procedure to perform the same test on multiple devices.
So there's a different type of electrical safety. Okay, depends on the model. Some models like they got different brand that fully automated standalone machine. Some are using software based through your laptop, and you can automate them. So it depends. Like the model that we show earlier is fully normally run on manually. But if you want to automate that particular device, you need to run in a different program, but normally it's not advisable actually.
Very good. I think it's about time to wrap up. Again, we will send you the slides and the recording. You'll get a follow-up email as long as you registered for this session. If you didn't give us your email, for example, if you're in a group right now and only one person gave their email, you can email us at assisthtm@assistinternational.org, and we'll make sure you get the slides as well. Benjamin, do you want to close this out for us?
Yes, absolutely. Thanks, Erin. A great presentation today. Thank you so much, Guna and Erin, for all the time and effort you've put towards this. Thank you to everybody who's paid attention and stayed with us this long, and to all of you that have asked questions. Thank you for asking those questions. We're missing some of our Ethiopian counterparts because it's a holiday. So we also want to just kind of wish all of our Ethiopian friends on this call happy Durge Downfall Day, and I hope you get to celebrate it as best as we can while observing the COVID-19 related social distancing protocols. We're thinking of you. We're thinking of all of you on this call. Stay safe. And next week, same time, we'll have another presentation for you. So looking forward to seeing all of you again next week. Thanks, Aaron. Thanks, Guna. Bye, everybody.